Well, we're going to do grade 11 exponent and surds, okay? And then we're going to do addition, subtractions, multiplication, and divisions of powers with numerical bases. Now, there's something that I would like to draw your attention here. It's like, you know, we're going to see questions of the form like a times b to the power of x, okay? Note that this is b to the power of x here will be the exponential variable because because the variable is x, is an unknown, is a variable, the exponent is a variable, and then this is by no means equal to we cannot do a times b to the power of x here. It's not the same thing, okay? It's not the same thing to do that. This a will be just a constant, and that b will be the base, and then the x here is the variable. Now bx, the whole thing here will be exponential variable, okay? Now this cannot be equal to that. Let me give you an example. If we have like 2 multiplied by 5 to the power of x, we cannot say this is equal to 10 to the power of x. No, that's wrong. I can prove it to you. Assuming x has a value of 2, for instance, or 3, to make it different, 3. So it's like having 2 to the power of 2 times 5 to the power of 3, and then someone may say this is 10 to the power of 3. Okay, assuming it is, and then 10 to the power of 3 equal to 10 to the power of 3 will be equal to 1000. Okay, this is one way. But on the other way, it will be if I keep it like 2 multiplied by 5 to the power of 3 is 125, and then 2 times 125 is 250. You see how the answers are different. So we cannot say we cannot combine these two. Now you'll see in this video I did the solutions of the question that you see over here. Thank you. Now let's start. Well, now we are going to do grade 11 exponents and surds, and then this part will be we'll focus on addition, subtraction, multiplication, and divisions of power with numerical bases. Now we have like the questions that we see here, 6 of them. Now question 1 says show that 5 times 2 to the power of x minus 2x plus 2 equal to 2x. Now it means this is true. The left hand side is equal to right hand side, but we need to prove it. Okay. Now let's start. I'll write here question 1. 1. Okay. It's 5 times 2 to the x minus, when you see here 2 to the x plus 2, this means we can apply this law of exponent that says, I'm going to write the law over here. Okay, let me first write the question. 2 to the x plus 2 equal to 2x. Now over here, I am going to apply the law of exponent that says, you know, a to the power of m times a to the power of n equal to a to the power of m plus n. Remember those, excuse me, those law of exponents are useful forward and backward, okay? So it can be useful if you look it from left to right as well as from right to left. So over here we have like 2 to the x plus 2. We are going to split this, okay, into this. It's going to be 5 multiplied by 2 to the x minus, instead of me writing 2 to the x, I'm going to write 2 to the x times 2 to the 2 equal to 2 to the x. Okay, So now this makes like 5 times 2 to the x, okay, minus 2 to the 2, we know this value is 4. So 4 times 2 to the x equal to 2 to the x. I just prefer to write 4 after 2 to the x because, you know, the variable is here. We usually write the variable after we do write the constant. Now note that this line here is expressed in terms of 2 to the x. 5 2 to the x minus 4 2 to the x. We can do 5 minus 4. Okay, this is just 1 2 to the x, or we can, someone else can say, okay, we're gonna take 2 to the x as a common factor, okay, equal to 2 to the x, and then there we'll have left with 5 minus 4, and then 5 minus 4 is just 1. So that makes 2 to the x times 1 equal to 2 to the x. This is, excuse me, this is proven. Left hand side is equal to right hand side, okay, because this is 2 to the x equal to 2 to the x. Proven. Okay, say left hand side is equal to right hand side. Proven. Now the following question is question B. Question B here says 9 to the x plus 3 to the 2x plus 1 equals to 4 plus 3 to the 2x. So it means that this expression, this equation here is true. We just need to prove why it is true. If you look at the numbers like 9 here, 9 is a square number. So it is, this is like 3 squared, okay? 9 is like 3 squared. So we can write here, 9 we can transform it, okay? And then 3 to the 2x also, I mean, see, I was saying 9 here, we can call it 3 squared, okay? And then 3 to the 2x, because of this rule of exponent, we can call it also 3 multiplied by 2 to the x multiplied by 3 to the 1, okay, equal to 4 times 3 to the 2x. Then there's another law of exponents which I'm going to write here. That says like a to the m all to the n equal to a to the m times n. Now this is the case we're going to apply over here. 2 to the 3 to the 2 all to the x will make 3 2x plus there I can write 3 in front, so 3 times 2 to the 2x equal to 4 times 3 to the 2x. Okay, now I can say this, there is an invisible one here. 3 to the 2x, same thing as 1 times 3 to the 2x. So we can say 1 plus 3, which is 4, or I can just factorize, okay, because of course there's that invisible one there. I can factorize. I can take this common, because the common factor, 3 to the 2x, 3 to the 2x, factorize. What should be there? It's going to be like 1 plus 3. 1 because I was saying that they were invisible one there, 1 times 3 to the 2x. So if we take 3 to the 2x, we don't, here it's not going to be 0, it must be 1, okay, because 1 times 3 to the 2x is still 3 to the 2x. If you say 0, it means all this here is 0, but this is 3 to the 2x, so the product is like 1 times that. Now this is equal to 4 times 3 to the 2x. Now over here, 1 plus 3 is just equal to 4. So this is like 4 multiplied by 3 to the 2x equal to 4 multiplied by 3 to the 2x. So we have like left hand side equal to right hand side. Also proven. Okay. Now we can do question C. Okay. I want to write it somewhere. Let me write it. Okay, over here. Question C is that one. I'll write it here. C is 2 to the 2x minus 1, okay, plus 4 to the x plus 1 equal to 2 to the 2x multiplied by 9/2. Well, let's simplify this. 2 to the 2x minus 1, we can split it. Okay, as we said, we can write it as 2 to the 2x times 2 to the -1. Okay, plus 4 to the x plus 1. 4 is not a prime number, so we can write it as in terms of its prime factor. So it's like over here to the power of x plus 1, we can write it it's 2 to the power of 2. So this is equal to 2 to the 2x, and then there multiply by 9/2. Okay, let's leave it like that so long. Over here, 2 to the power of -1 is just a half. So we can write here a half times 2 to the 2x plus, there we can multiply the exponents. Okay, that makes like 2 to the 2x plus 2. Be careful here. When we multiply the exponents, it's basically we are going to do 2 multiplied by x plus 1. Okay, it times everything. You cannot say 2x plus 1. It's 2 multiplied by these. And then this is equal to 2 to the 2x multiplied by 9/2. And then that makes a half times 2 to the 2x plus, that makes 2 to the 2x plus 2, because it's going to be 2 times x and then 2 times 1 there. And then this would be like, let me just write 9/2 multiplied by 2 to the 2x. I can write the constant in front. Over here, then we can split this as we did for this step and previously in the previous question. So it's going to be like a half times 2 to the 2x plus 2 to the 2x multiplied 2 to the 2 equal to 9/2 multiplied by 2 to the 2x. Then 2 squared here is just 4, so we can write it as so it's going to be like a half multiplied by 2 to the 2x plus 2 to the 2x. No, let's just first write 4. 4 times 2 to the 2x equal to 9/2 multiplied by 2 to the 2x. Now it is an equation. We can get rid of this denominator here, 2 and 2 here, if we times the whole equation by 2. Okay, we can times everything by 2. We can times here by 2. Why by 2? Because I wanted to get rid of this denominator. I know if I times by 2, this will be just 2 to the 2x plus what? 8 times 2 to the 2x, because 2 times a half we cancel, and then are left with 2 to the 2x. This 2 here, when I say times by 2, it's like times by 2 for 1. Okay, so the same thing. 2 times that we cancel, 2 times 4 there, it makes 8. Okay, so this equal to 9 times 2 to the 2x. Okay, then notice that this is 2 to the 2x to the 2x. So we have like 1 2 to the 2x. Okay, plus it's like 1 times 2 to the 2x plus 8 to the 2x, which makes, we can factorize, or we can just say this is equal to 9 times 2 to the 2x, equal to 9 times 2 to the 2x. And then this is proven. Okay, so L left hand side equal to right hand side. That was question C. And then the same way we will do question D. Let's do question D. D is given by 2 to the x plus 3 minus 2 to the x plus 2 equal to 2 to the x plus 2. Okay. Over here, we can do as we did previously, or we can do something different. We can write it like, you see, over here the exponent is x plus 3, right? So we can write it as 2 to the x plus 2 plus 1. Okay, I wanted to have this to be let me highlight this this to be same as that and that also. So I say 2 to the 2 to the x plus 2 plus 1. We can write it like that because you know 2 plus 1 makes 3. Okay, minus 2 to the x plus 2 equal to 2 to the x plus 2. Now this can be, we can split it. It's going to be like 2 to the x plus 2 times 2 to the 1 if we split, minus 2 to the x plus 2 equal to 2 to the x plus 2. Then it's like we can write the 2 in front, so it's going to be 2 multiplied by 2 to the x plus 2 minus 2 to the x plus 2 equal to 2 to the x plus 2. Now, this is like one thing, okay? There is an invisible coefficient there of 1. We can just use 2 minus 1, which is 1, or we can factorize. Here, take 2 to the x plus 2 as the common factor, okay? And then it's going to be like 2 minus 1 here equal to 2 to the x plus 2. Okay, and then 2 minus 1 is just 1, and then 1 times anything, okay? All this just makes 1, and then 2 to the x plus 2 times 1 is just 2 to the x plus 2, and that's equal to 2 to the x plus 2. Now we can see that left hand side equal to right hand side. Done. Okay, or we could also split it like x to the 2 to the x. Let me do this way. As we were doing previously, we could also do 2 to the x times 2 to the 3 minus 2 to the x times 2 to the 2 equal to 2 to the x times 2 to the 2. Okay, times 2 to the 2. From this line, from here we can write this way. Let me just move it a little bit there so we can see. Okay. After given, this was given, and then in this line, we could write this way. And then we know that 2 to the 3 here is 9. I mean, is 8. So it's going to be, we can write 8 times 2 to the x, 8 in front, because it's just a number, minus that also 4. 4 times 2 to the x equal to 4 times 2 to the 2 to the x. Now, because this and this are just the same thing, okay? We can do 8 minus 4, you know. 8 minus 4 is just 4. 4 times 2 to the x equal to 4 times 2 to the x. And then we also prove that left hand side is equal to right hand side. Okay. Let's do the next question. It is question E. Okay, here is question E. E is 2 times 10 to the x minus 5x plus 1 multiplied by 2 to the x equal to negative 3 times 10 to the x. Now, what we can do here, let's first split this. It's going to be like 2 times 10 to the x minus 5 to the x times 5 to the 1, okay? Minus times 2 to the x equal to negative 3 times 10 to the x. Okay. Now, I want you to look at this term here. This term, it's a product, right? Now you notice that this is power 5, this also power 5. So we can combine, we can do 5 times 2. Remember this law of exponents, the law that says A Okay, let me write it this way. Okay, the loss is a times b to the power of m equal to a to the power of m times b to the power of m. Okay, so here we have this form, the form that we have in the left, in the right, I mean 5 to the x times 2 to the x. So we can combine that into what's in the bracket here. So we can just write here 2 times 10 to the x minus 5 multiplied by 5 times 2 to the power of x equal to negative 3 times 10 to the x. And then this will make like 2 times 10 to the x minus 5 times 10 to the x equal to negative 3 times 10 to the x. Okay? And then we can do here, we can factorize, we can take 10 to the x as a common factor, or we can just say, because this is it's end with 10 to the x. Think of 10 to the x here as just one variable, let's say y, or let's say variable n, for instance. Let's think of it as n. Sometimes we can substitute even n, and then say to yourself 2n minus 5n is how much? It's going to be negative 3n. So this is like negative 3 times 10 to the x, okay? Equal to negative 3 times 10 to the x. Now we can prove that left-hand side is equal to right-hand side, okay? Somewhere we can do a question F. Let's see. We have this. Okay, right here, F. 4 times 3 to the 1 minus x plus 3 to the 2x, no, to the 2 minus x equal to 21 over 3 to the power of x. Okay, so we can split this, okay, as we did in the previous questions. So this will be 4 times 3 to the power of 1 times 3 to the negative x plus 3 to the power of 2 times 3 to the negative x equal to 21. 21 over 3 can be written as 21 times 3 to the negative x. Remember this law that says 1 over a to the m equal to a to the negative m. So 4 times 3 to the power of 1 is just a number. So if you do 4 times 3 to the power of 1 is just 12. So this is 12 times 3 to the negative x plus 3 to the power of 2 is 9. So that makes 9 times 3 to the power of negative x. And then that makes 21 times 3 to the negative x. Now 12 plus 9, okay, as I was saying, we have this and we have that. Think of that as a variable, okay? A variable, we can call that variable n, okay? It's like having 12n plus 9n, and this is equal to 21n. So we're gonna say 21n, but we're gonna say times 3 to the negative x equal to 21 times 3 to the negative x. Done, okay?